Welcome to your go-to podcast for the pool and spa industry. My name is Tyler Rasmussen.
And my name is Greg Villafania. And this is the Poolchasers Podcast.
All right, well, thank you for joining us today on the podcast, Richard. We really appreciate you being here.
Thanks for the opportunity, guys.
Yeah, absolutely. So we know there's a ton of history at LaMotte Company, and we kind of like to walk down memory lane with you a little bit. So would you mind starting at the beginning, kind of in 1919 when the company started?
Right. It was my grandfather, Frank LaMotte. He was working for DuPont up in Delaware. And what happened was he was doing some work in a division that was making or using some pH indicators in the work. And what happened was with the war breaking out, the Germans really had the only pH indicators that were being produced and made to be used anywhere outside of a laboratory. So he pitched the idea of starting a new division or a part of DuPont to have these pH indicators, and they didn't go for it. So he said, well, I'm going to take some time off and start a company doing this. So he had a house not far from Baltimore and went ahead in downtown Baltimore and started making pH indicators and quickly, obviously, doing pH test kits, initially for different applications like drinking water, public health applications. But that's really where he got his start, was just he wanted to go do his own thing, and so he left DuPont temporarily, I'll say.
Yeah, that must have been the true test for all of those different things back in the early 1900s, right?
Yeah, there was a lot going on. That was amazing if you look up in the history books what was going on during those time periods. I mean, if you think back and look up things like, that's back when the I guess there was, even before Prohibition, I think it just started. So, we could have pH indicators, but you couldn't drink, and different things like that. But I think what's neat is that he got started in downtown Baltimore with a couple of chemists, and then DuPont called on him again in the mid-20s after he had the company started and doing pretty well, and asked him to do a project out in Montana on tannins. I guess they were extracting tannins from tree barks and things like that. And I guess it was important enough to DuPont where they made him an offer he couldn't refuse, said he'd only be gone for about a year, and a year turned into about 4 or 5 years. And during that time, he was in constant touch and still at president, for LaMotte Company. But what happened was one of his key employees then was actually a Mr. Taylor. And a Dr. Taylor, who was working as a chemist for my grandfather, who was, of course, a chemist himself, he decided after my grandfather came back that he wanted to start his own company. So he left our company in 1929 to go start Taylor Chemical, who makes all the Taylor test kits these days.
Wow, that's pretty crazy history. I remember you told me that on a previous conversation we had, and I thought that was very interesting. I mean, what was their relationship like moving forward then after that? Was it pretty competitive, or were they still friends?
It was competitive. I think he had, I think he had another chemist that went with him that was good. So it was competitive but polite. There was not exactly, they weren't hugging and kissing, but they were certainly competing one-to-one on a lot of different things. And Dr. Taylor had a way he wanted to do things, and my grandfather, he had a way he wanted to do things. So it just it worked out in the long run. And right now, we have other competitors just in the commercial pool side. Obviously, Dr. Taylor's group is still going strong and under new leadership up there. But years later, we moved from that area across the bay. But in those 20s, we started doing things like we made some test papers for chlorine. We did a lot of different things. We started doing some things with blood chemistry. There was a lot of interest in testing different things in the bloodstream. And then we went into, in the late 20s, early 30s, into some soil testing as well. And so what happened was I remember hearing that in those early days, the company was successful enough that during the Depression, we had strict instructions to go to the back of the bank in downtown Baltimore and with a special knock on the door and get in, because there were people having runs on the banks in the front door. So we had to be very careful about, it's just like today with a pandemic, some companies are making money and other companies are really struggling. And at the time, we got through it because he had a unique chemistry that everybody wanted and the health departments wanted. We were doing a lot with the health departments in the late 20s. They were checking on drinking water as well as swimming pools. And Frank, my grandfather, he was a graduate of Johns Hopkins University, and that, as you know, is in downtown Baltimore. And he also had some good friends there. And one of the guys there, I believe, was Dr. Inslow. He was one of the ones that first created the systems to chlorinate drinking water. And so he came and worked with my grandfather to do a OTO chlorine test and combine that with a pH test for swimming pools so they could have the first OTO pH test kit sometime there in the late 20s, early 30s.
Wow. I'm curious, was it a pivotal moment when there was that transition from using glass to plastic? You know, the way that, you know, you have the, you know, the different chemical or testers and things like that. Was that a big sort of change? Because I imagine that glass has to be much more expensive than, you know, plastic containers.
Yeah, we still have glass in a lot of our tests, not in the pool industry, obviously, because the pool industry does not want a lot of glass tubes breaking right next to the side of a pool. But in other areas, we still use glass for some of our industrial kits and other kits, and it's because the reagents themselves can cause staining, and so they really could cause staining much quicker on a plastic than it would be on glass. So really, it was probably not until the 60s, maybe the mid-1960s, that we started migrating over to plastic tubes around pools. For a long time, it was just a matter of grab your sample, stay away from the pool, and don't drop the vials.
Right. It's funny. We were actually looking on eBay and Etsy and different things like that, and we typed in LaMotte, and we got to see a bunch of vintage, old, like soil testing kits and all these things, and they're in wood boxes and all this crazy stuff, and it's just really cool to see that little piece of history right there. Somebody's been hanging on to and hoarding for a while.
Yeah, we have a lot of people that sell those, and they contact me every once in a while to try to get a date on them. And what happens is, oftentimes I can get within a few years, 4 or 5 years, maybe a little bit wider, but what happened because the company transitioned, you know, as a lot of companies do, from one logo to another logo to another logo. And so some of the first early kits had a little diamond-shaped logo called LaMotte Standards. And then they went to LaMotte Chemical Company. Of course, now we're called LaMotte Company. But each time you have these logo changes every 5 to 10, 15 years, we can identify and date some of those kits. And so these people do sell some of these kits from anywhere from $30, $40 to maybe $100 or more online. A lot of doctors, dentists, and other types of chemistry folks love buying these antique chemistry kits. And we, of course, have a lot of them out there since 1919.
I bet. Very cool. Very cool.
For sure. So did you guys introduce the actual first pool test kits then?
Yes, we did. We had the first portable pH test kits in the U.S., and we did the first pool test kits, and that was in the late 1920s. We did the first pool test kits. And the combination chlorine and pH was something I think the health departments were looking for, and that was the first time we ever did a combination kit being 2 factors. It was driven by the pool industry. So the pool industry has been driving our creativity for a long, long time.
And why is that exactly?
I think back then there was a lot of demand. Pools were getting kind of in vogue in the early 1900s. There was a lot of old movies out, and things like that, the old black and white movies maybe. But there was a lot of, let's say, just safety issues with it too. So the health departments had to be very careful. You had these large pools, which they still have a lot of these over in China, where hundreds of people go into. But it was a concern, and anytime you have public health and safety as a concern, there's a usual rapid need for some type of device to check it. Just like our pandemic and our COVID right now, there's a rapid need to really understand what is going on chemistry-wise to go ahead and protect the owners or users of the pool, I should say. But one of the things that happened around that same time in 1929, a group for the Admiral Byrd expedition contacted us, and they said, look, we want to have one of your pH test kits to take down to the South Pole. So Admiral Byrd took one of our pH test kits to his little place there. It was called Little America down the South Pole. And we're glad he didn't die, because we were able to get the kit back, because he almost died of carbon monoxide poisoning once. I guess, I don't know, maybe a rogue seagull sat on his stovepipe or something, but But yeah, so we did get the kit back and have it in our archives now, and it's in really good shape. You could still use it. Yeah, we broke out a bunch of the oldies but goodies last year because that was our 100th anniversary. And so we do. It's kind of small. It's just a few items we have in a cabinet. But there's other ones that we've kind of let go of over the years. Some more recently. For instance, we had Steven Seagal using one of our test kits in a movie, and in the movie, the movie was A Fire Down Below. I have a picture. I have a picture of. I'll show you later. I could send it to you to follow up with. But what's funny is this was out in Kentucky. It wasn't one of his best movies, I have to admit, which is the sad thing. and in some of the episodes, it's cut out. But I do have a picture of him using it during the movie. But what's interesting is he's a huge guy, and they asked me to come out and show him how to use it. But I sent a technician out there because it was a time I couldn't do it. This was being filmed out in Kentucky, and so he looks at this big kit, he opens it up, and he sees a test for cyanide, and he immediately throws his hands up and says, whoa, wait a minute, this is going to hurt me, and here's this guy 6'7". It's like, it's the test for cyanide. It's not the cyanide in the test. And so the girl who was working for us who went out there to do the training, she said she went to the food line and was standing right behind him in line and didn't realize it until she turned around and she realized her head came up about halfway to his back, And she said the people on the set were kind of funny in that he wasn't supposed to be wearing that black jacket for the whole movie, his leather jacket. He was supposed to be an EPA inspector, and he said, hell with you guys, I'm wearing the black jacket. So they're like, okay. But yeah, we also had some of our vials, some of the pH vials or colored vials we used were in the opening of The Deep. That was a movie back with Jacqueline Bisset, and anybody likes the beginnings of an exciting movie, they have a lot of video of her jumping in the water with Nick Nolte and picking up all these vials that were supposedly opium or something like that. And for some reason, they contacted us, and we made all these vials for them. So occasionally we have something more exciting than swimming pools to play in. Yeah. Well, it's funny you mentioned that because years ago, this was probably back in the 70s, right before I got here, we got a call from the health department or CDC of Canada, and they were very concerned because evidently a truck had overturned in Toronto, and some of our DPD tablets had fallen out into the street, and people had picked them up and took them into bars and trying to sell them as drugs. And so they found people at these discotheques and bars trying to actually, sell this type of stuff. Not too good. I guess if they had some chlorine in their body, they peed pink. So that I don't think they got too far with it. Thank God. But I was going to mention, you mentioned the soil test kits too. That was kind of interesting because during the old days of when we had the Depression and the Dust Bowl, there was a lot of demand to understand what could be put in the soils to make them more productive. And so we started making kits that tested not only pH, but nitrate and other things. And what you would do in that case, you can't just stick reagent under the soil. You actually create like a slurry. Imagine like a little spot plate where you place the soil into this little plate, you add a bunch of reagent to it, and then you tilt it and you siphon off the color that comes out of that soil. So there's different ways to do extractions, but that's what we got into long ago. We still make some soil kits for some gardeners. This year with COVID, all of a sudden the gardening industry took off, so that was something that caught us off guard. And a couple other things. Obviously, the pool industry took off quite nicely this year with COVID going on. So that's just a little update on that.
Yeah, very good. And I'm curious, the Dust Bowl, I wasn't too familiar with that, but I've heard of people recently getting like valley fever and different things like that from like digging in dirt and not knowing what's below. And that's kind of more of a Arizona issue. But I'm just curious what kind of, diseases or were there things happening during that Dust Bowl?
It was mostly just an extreme drought. I wasn't around then, but what I read was extreme drought. And so what happened was with the winds and drought, it blew a lot of the soil, the topsoil off the fields. So it was more like a drought-stricken Midwest where this wind was blowing all the dust around And imagine like a snowstorm that was constantly just dust and dirt, and it was killing the crops. So the crops were dead mostly from the drought and from the lack of nutrients left in the soil. So it was a combination, bad nutrition in the soil and windy, dry conditions.
Wow. That seems so scary. I always think of the movie Interstellar. Have you ever seen that?
Oh yeah.
No, I haven't.
They
No.
just have these crazy, it's supposed to be, like year 3000 or whatever it is, but they just have this really bad problem of having crazy sandstorms.
Oh,
And
yeah.
I'm like, I don't ever want to live in a time where we're dealing with high winds all the time.
Yeah, I remember seeing a video of a wedding over there, and not far from you in Arizona, where a dust storm came in right during the wedding. It was pretty fascinating.
Don't have a wedding during monsoon season or do it indoors.
Yeah, the haboobs are a little taste of that for sure.
Yeah.
So what is the soil test? What was it used for back then, though? What were they trying to figure out from that?
Yeah, what they're focusing on is a couple of things. pH, by far, number one, is that certain crops do better in certain pHs. So they need to say, if they can't afford, like if I'm a farmer and I have a certain pH, let's say around 6.5, I might be able to do well in this field with, let's say, corn this season, but I can't do alfalfa. Or if I want to do corn, I know I need to go out and buy a bunch of chemicals to treat it. So they take these samples throughout the field, realize, okay, I'm low on nitrate, I'm low on pH. If I want to really grow things well, then I have to have this field tuned in. These days, they have things much more advanced. These guys will send off samples to universities, but now they have even systems on plows that, as it goes through the soil, it can test some of the soil basics and figure out what's best to plant here versus there. So they really have come a long way from the old days of just taking a pile of dirt out and testing it in a lab.
Wow, that's incredible. I feel like there's like so much tech in the farming industry. They've really had to roll with a lot of punches. And I feel like I'm always hearing about innovations in farming, but that's really cool that they've got a rig that will actually pick up that data from the soil.
Yeah, that was something in the news I saw recently. It was fascinating news, but the tech in these plows and other types of devices in farming these days is pretty interesting. I don't know how they can afford it. So it's one thing just affording a nice pickup truck, but these things are amazing.
That's the real first self-driving autonomous vehicle right there. We're trying to do it on the roads, but farmers been doing it for a second now. That's good.
Yeah, and I think now they're looking at things. I've seen things like drones that will go out and plant either crops or reseed forest. That can drop plugs into forest. So there's a lot of interesting things going on in soils, but I know we're into pools, so I better get back to that part.
No, it's part of the history. I mean, you look at that. That's a vital part of our U.S. history. That you guys help prolong and help these farmers, grow their crops and continue to feed, America during those hard times. So that's really cool that you guys were, adapting to blood tests and soil tests and other things we'll get into. But it's really to be open to something like that is impressive in itself, that a company would take that challenge on and develop those things.
Yeah, and to finish that thought, the reason why homeowners still use these today, different kits like ours for testing soils, is if you have a garden, you might want to plant, tomatoes and all sorts of different vegetables in different parts of the garden. But unless you know what type of pH you're dealing with, and nitrate and phosphorus and all those, you could have a really crappy crop, And so, for instance, if you're planting trees around your house, if you want to have azaleas, you better have a really low pH because they do not like normal pHs. So there's certain plants that will be very successful and unsuccessful in soils, and that's why a lot of our equipment does go to schools and high schools where they work on projects testing what plants are good in what soils. And it's so we do sell a lot of the soil testing equipment to the VOTEC and high schools and that just to help educate our students.
Wow, that's very, very cool.
Yeah, and so what kind of happened after, the soil test kits?
Yeah, so back in the 50s, what happened was, which was kind of exciting, was we were actually making our own pure phenol red. We weren't buying it from other manufacturers overseas. And so we got a call, I guess, from the Jonas Salk vaccine people. So here we are in vaccination, mode all over again. But as you know, he had the polio vaccine. They found out early on, I guess they didn't have 80 degrees below refrigerators, but they found out that if they had a phenol red indicator in that vaccine, they would be able to tell if it had gone bad before use. And so we were all of a sudden making tons of phenol red for the people in the Jonas Salk vaccine. So that was a big plus for us. It's one of those things where you kind of fall into something, because we were doing some medical industry devices back then. We were testing blood chemistry. We had a test for syphilis and gonorrhea. I guess that was popular in the military. And we did a lot of those blood chemistry things, but then finally got out of it. Back in the 50s or so, we were doing antigens, which meant you had to take material from a pig and do these immunoassay types of tests. And we got out of the medical and chemistry area mainly because the FDA, it was clear that was going to be a lot of hassle working with those guys over the years. So we like the pool people a lot better than the FDA people.
For sure.
I bet.
That's pretty interesting. I mean, for those that don't know, can you explain what phenol red is and why it would help in those cases?
So phenol red is the pH reagent that changes. It's very sensitive. It really can read anywhere from like about 6.4 to about 8.5. And there's pH indicators in each of those ranges. Like we have bromethymol blue, cresol red. There's one for each of those ranges. Whereas a pH meter can go from 0 to 14. If you're doing it chemistry-wise, you have different pH indicators for different ranges, like one that's like 0 to 3, 3 to 4, 5 to 6, and then phenol red just happens to be the one that's 6.5 to 8.5. So what happened was, I guess, let's say the actual Jonas Salk vaccine maybe had to be kept in maybe an acid. I don't know this for sure, but it's probably one way or the other. But if you had a nice yellow vaccine, then probably it was fine. But if it started turning orange or red, then maybe that's when they had to throw it out. So most people who are, managed pools before know you've got a yellowy orange to red color in phenol red, and that's telling you the pH is either much higher, in the high range. We know it causes, some problems with, let's just say, things settling out in the pool, whether it can do a lot of harm, clog up the pipes, whereas low pH can corrode the pipes and do all sorts of aggressive things to the pool. So it just so happens 7.0 is neutral, but 7.4 is much more effective for human bathers. If you wanted to run a pool without people swimming in it, it'd be better to have it at 7.0.
Very good. Yeah, thank you for explaining that.
Mm-hmm.
And what's the next step in the history?
Well, what we did was, I guess with the success around the Jonas Salk vaccine, and in the early 50s, my grandfather decided, if you're familiar with the geography of Maryland, it's almost split in two sections. It's kind of a really odd shape, but we're cut across in half by the Chesapeake Bay. So Baltimore and D.C. are on the west side of the Chesapeake Bay, and over on the east side is what's known as the Eastern Shore. It's actually an island, but you don't really know that because it's the C&D Canal kind of cut across the top of us. But what happened was he found this beautiful piece of property here in Chestertown and fell in love with it and bought it, and actually was commuting over to Baltimore about an hour and a half to 2 hours each way, 3 or 4 days a week. And that was something he was doing for a while. Finally, he decided to move the company here in 1956. So that was probably at the time he maybe had a couple dozen employees. When I started here in '84, we only had about 50, and now we're up to about 240.
Oh, wow.
So that was 56. That was the big move, and the blood chemistry, actually, that's when we kind of stopped doing a lot of that, and we really started to do a lot more with drinking water and swimming pools. And in the 1968, one of our chemists saw an article about this guy over in England who had just created this first test for measuring free chlorine. And our chemist, Doc Kenny, at the time said, hey, look, we need to talk to this guy. If we could get our hands on this test system that he's using, we could actually really make some inroads here in the United States. And so he was, my grandfather and Doc Kenny called this guy up. His name was Dr. Tom Palin. You may have heard of the company called Palin Test. That's who was the originator of that. but he had created this DPD, it was called diethyl P phenyldiamine test for free available chlorine, which was the active amount of chlorine, which OTO really couldn't measure that well. And what happened was he designed it primarily for the drinking water industry. He was in the actual drinking water treatment industry for like municipal waters, things like that. I met him a few times in the early years when he would come over on visits. Very gentlemanly, elderly guy, just great character. And so we got the exclusive to bring DPD into the United States in 1968. And we worked with them for a long time. Then by the mid to late 1980s, they were making other tablets, and some of their chemistries were like, hey guys, this is good, but it's not quite what our people want, let's just say, rather than say it wasn't working as well as we expected. And so they were like, well, heck, our patent's running out on DPD. We want to come into the United States. So we could see that happening. So in 1988, we started setting up our own DPD tableting operation here and started making tablet reagents in 1988 and have been ever since.
Yeah. For those that are unfamiliar with that, how does that process work?
So what happens is, first of all, it's a big investment. What happened back in 1981, 82 is there was a company called Thomas Scientific, or Arthur H. Thomas Corporation, and they are still our owners. They actually bought us back then, just about a year or two before I came on. And what they did was they were able to infuse money, and they were the ones that said, hey, look, this is what these guys are doing. Here's $500,000. Let's go make these machines and make this happen. Whereas as a small company, on your own with just a couple of, let's say, some family and other part owners, because what happened was when my grandfather had sold it off to, I guess it basically handed the company over to my uncle and some other members of the company, just here's your stock share, here's your share and all that. They had to make the decision then back in 81, 82, do we sell off to this big Thomas Scientific Company, which is a really large equipment company that sells laboratory equipment. And so they went ahead and made that decision, but those were the guys that said, okay, no problem, here's a check, go make your own DPD. And same thing happened when test strips came along, and we saw the market demand for test strips back, in the next decade, in the 90s, we saw all of a sudden a lot of demand for test strips. They're like, okay, here's a check, go make it happen.
Wow. That's so cool. And, since we're still kind of in the history, I'm curious, how competitive was the marketplace, competing with other, manufacturers of like kind of in the same space as you? What was that like? Because, you're going after, military contracts and different things like that. From a business perspective, you're juggling being innovative in this space as well as trying to keep the lights on, right?
Right. Yeah, so there was, during that time, let's say in the early 80s, going back to then, obviously Taylor was a big competitor in the pool market. They were putting a lot of effort in there. They were focused on the swimming pool market and the industrial water treatment market, which means the boiler, cooling tower guys, these guys that take care of, they didn't really do anything in drinking water. They mainly dealt with the industrial water processes. But they really focused hard on that. Meanwhile, we were a little distracted into working in the soil area, the science education area. So we were very diverse, which also meant we weren't, let's say, chasing after the public pool market as much as Taylor was. So we were also going after the drinking water industry, which another company called Hawk, they were going after. Hawk ultimately bought out ETS, the test strip company you probably are familiar with. But Hawk was doing a lot of what I call inline and fancy equipment, which meant that they were doing machines where you could put it into a water treatment plant. It would take a sample in, run that DPD reaction, and then flush it out. So they were focusing on high-end equipment. We decided we'd go in the middle of the road. We were going to try to take some better equipment from the simple chemistry by doing electronic meters and things that Taylor was not doing.
Very good. I have a crazy question, because I do this from time to time, is ask crazy questions. Somebody being in this space, do you think it's ever possible to take the ocean water and convert it to, actual usable water for taking showers and drinking and different things like that, but on a mass kind of worldwide scale? I'm just curious what your thoughts are on that, because I feel like people don't quite understand kind of the kind of the drought that we can be in sometimes, and it doesn't really get talked about. Water is kind of a precious commodity, and I'm just curious what your thoughts are on that.
Yeah, I think there's going to be, hopefully there's some more research into that, just like wind energy and other types of alternative, energy sources. What's happened is if you do some research online, they're called desalination plants. They desalinate, basically take the salt out of water. They have some of these. I remember seeing one down in Aruba. I believe they have some out on the West Coast. I haven't really paid too much attention to them. I know it takes a lot. It takes a lot of energy and takes a lot of money and equipment to set up these things. So right now, the water supplies are cheaper finding them elsewhere. But in the future, I think they need to come up with something like that. One of their challenges is that if you probably ever went out in the ocean and got hit by a wave and tasted and swallowed that water, there is a lot of dissolved materials in there. And you can imagine it's really hard to get all that out, especially the salt. And when you have high levels of salt, to kind of get that down to a level where you could drink it is quite a task. Whereas for using it for other, let's say, gray water applications, that's what they call things like water in the lawn. I was recently looking at a water treatment system for my house, and they said, you got to get this. Unless you have a sprinkler system, you got to get the bigger one. I'm like going, whew, thank God I don't have a sprinkler system. But you guys out there in Arizona, there's probably ways to set up a system where you can use that in a sprinkler system, but it needs to be properly conditioned and cared for, because if not, those systems can go bad. A lot of the sprinkler systems, the real expensive ones, do track their water chemistry pretty well, because if you invest tons of money in a very high-end sprinkler system, some of the ones I'm talking about, there's above-ground ones you see out in fields, that can be very costly if the water quality is not good in those sprinkler systems. So going back to desalination, it is a good idea, but to show you how hard it is, that's why some guy was one time trying to get money to bring icebergs down to melt those. so I think it's worth you investing in. So go ahead and invest in desalination and let me know how it works. Because it could be good. It's going to be good one day. It's got to.
It's wild because you might have a gallon of water, ocean water, but you only might get an ounce of usable water.
Right.
Like it's pretty rough what's actually usable. But thank you for sharing all that. That was great. Thank you.
Sure.
So from DPD, and you guys started making your own. Where'd you go from there?
So obviously, right after doing DPD, we had to pounce on phenol reds because we knew right away we had to have both of those tests. And so right after the DPD, phenol red became, we had to do alkalinity, hardness, all those tests like that. Now, the original tablets for our alkalinity and hardness, you may not know this, they were what were called add tablet tests. And this is what Palin Test, the company over in England, was trying to get us to sell to all the service guys. They said it's no problem. You take a little glass of water, you add a tablet in. Was it 10 parts per million? No. You added another tablet in. Was it 20? No. You guys would be out there for an hour adding tablets, 10 parts per million. So I was like, our guys are not going to do this, guys. And so it just was a really, let's say, archaic, and just the whole idea behind it was like, guys, we got to do something better. So we did, and I think they did too, also work on colorimetric alkalinity and colorimetric hardness. And the reason why you hear sometimes people saying, well, titrations are better than colorimetric tests for alkalinity hardness. They can be, but it's because if you looked at, let's say, calcium hardness, and let's say you're looking at a scale of 0 to 800, there's only so many colors you can get between 0 and 800. Whereas with a titration, you can add those drops one at a time, keep going, you can dial it in pretty good. The problem is in higher levels when you're doing titrations, the accuracy of the dropper tip and of the person using it can get a little bit fluctuated. And so, but the precision you can get in a professionally done titration with a large burette is always going to be better on a hardness and alkalinity than on colorimetric, because of the, you can only, like with alkalinity, you can only get so many colors between 0 and 200. So it's a trade-off, but that's where we started. We started doing all the pool test tablets first, and then started getting into things like nitrates and other things that were other demands in the market. But we went all out doing all the tablets for the swimming pool kits, and we started producing the tablet pool kits for the U.S. which were really popular in public health applications like public pools. But the service guys, they didn't want to sit around and wait for a tablet to dissolve, because in the early days, those tablets took a while. It was a while longer before you could add some effervescence and things in there that would help them break up better, faster, because service guys just did not have the time to be waiting around for these things to dissolve.
Right.
Wow. So you guys took those steps in developing these different and advancing it, huh? Keep advancing the technology. That's pretty impressive.
Right, and a lot of that came from, the trade shows that we went to were, to me, one of the most valuable things we did back in the days, and unfortunately we haven't seen those these days. But I know the first one I went to was in Atlantic City in 1985, because I joined the company in 84, but in 85, and first time there, these guys kept coming up and say, don't you have something we can just stick a probe in or shoot our water into to do a test for us? I don't want to like add all these drops and put all these tablets in. Look, I got a lot of pools to clean. I don't have time for this crap. And so that was always the goal, is, okay, how do we make this faster without losing accuracy, or at least without losing all the accuracy? Because in some cases, test strips, you do lose some accuracy, but you have a much more effective quick test for qualitative, here we are between 1 and 1.5 on chlorine, whereas in a public pool, they want to know much finer increments because they're looking at how much combined chlorine is in there and all that. So yeah, the goal was always to make things faster and easier, and our goal has always been make it so they don't even have to read a manual.
Nice. So is that where then the test strip idea started to become more engaging, where you guys started to hear more from the service side, and that's when that development happened?
Yeah, so what happened there is we have to give a hats off to Miles Laboratories. They started, the guys from there started doing some test strips that were then started by ETS, Environmental Test Systems. And Mark Stevenson and his father and a few others there did a great job taking what was at one point kind of a mediocre type of test strip and really improving it. And that caught our attention, and it was actually one of the directors of our parent company, the Arthur H. Thomas Company, who owned a pool, who basically said to our president, it was like, guys, why aren't you doing this? And we're like, well, we'd like to, but it could be really expensive. And he's like, tell me what do you want on the check? So really it was a guy who didn't even work here, our parent company guy, who said, we want you getting in the test strip business. And so that's what we did. So we were able to get him in there, get, I guess, a few chemists that we needed. And it really was a tough go, because you really had to go from liquids and powders and tablets that we're used to laying these chemicals down onto a paper. And the way this all goes down, just to kind of give you an idea, is imagine like a little small bucket, something maybe the size of maybe 4 inches by 4 inches. You have to have just the right formulation in that little bucket, and you have pH meters, and you're testing it constantly. And the paper comes through, dips in there, then comes back out the other side and goes through this massive set of tunnels to dry. And that's just for your pH pad, right? So one at a time, it has to go through this huge machine very carefully at a very slow speed, and that's just for the pH pad. And so then you cut it up, and you have the chlorine pad, the pH pad, the alkalinity pad, all those. But our big feature, which I was pushing for and our chemists were able to pull off, was we wanted to take things from 30 seconds to almost a minute down to instant. And that's what our guys were able to pull off. Guys, I should say girls and guys, because we have one of the chief chemists there was a lady, Lydia Johnson. But they were able to design a strip where you could dip it in, pull it out. Well, actually swirled it. The initial one was swirl. You pull it out, and you could start reading the top pad, chlorine, which you want to read right away anyway. And by the time you got down to the bottom to read pH, it was ready, because it needed about 5 seconds or so to develop. So that's what we launched in 1996 at the trade show down there in a place called Phoenix, Arizona. And so that was quite the big launch for us, and really helped us get a good foothold into the industry, was because we had a faster strip that was competitive. And then it was just a matter of battling out with ETS for part of the market share until both Taylor and ITS, the guys in South Carolina, actually came into it.
Wow.
I could just picture comparing it to like a Polaroid picture and how long it takes to, load. When you take a Polaroid picture, it's probably, I don't know when those came out, but I could see those being
right.
side by side, seeing which one loads faster.
Yeah, those are antique collectibles now. It's just a matter of finding the film for it, I guess. But yeah, that's what it was. And I think but if you look at it from a serviceman standpoint, rather than sitting around adding all these drops, if he could put a strip in, pull it out, and wait 30 seconds, that was a lot faster than putting all these drops in and doing all that. But, what's interesting is some of the funny stories we heard over the years after strips came out. We had, some guys from both dealers and service guys. They were telling us that they would cut them in half lengthwise so they could get twice as many strips out of their bottle. And then this one guy, he came to the show at Atlantic City and said that he had a woman come in and brought in the strips and said, these don't seem to work well because the first time I dip it, they match fine, but the second and third time I dip the strip, it doesn't work as well. So she's using the same strip over and over again.
It's not reasonable.
Yeah, I mean that's the other fun part of the trade shows. You get to hear some of these stories like that. One I meant to tell you on DPD, it was in the 1980s, was that this guy up in Connecticut, he contacted us, and he had been a long-time DPD customer. He had a lot of our kits he sold to the public pools up there, and he had this guy calling him, kind of cussing at him, saying something's wrong with your chlorine. And this is a big public pool this guy has to take care of. I mean, the guy with his company's called Pool Doctor. And he said, okay, I'll come right over. I'll see what's going on, what's wrong. And so he shows him. He does the test, and he sees there's no chlorine in there. And he looks in the skimmer, and there's all these pucks in there. He's like, well, I don't know what's going on. So he said, well, show me where the chemical is. Because you did buy this chemical from me, right? So they were getting ready to get in this argument about the chemical not working. So he goes into the little room off the pool side, and he sees these two trash cans put on the wall. One said chlorine pucks, the other one said urinal pucks, so you can guess what was actually in the skimmer.
Oh, what? Dude, that is insane.
Not
much chlorine in those urine
I know,
pucks.
really. I don't know. That's if you want to get pee out of a pool, it probably wasn't a bad idea. But yeah, poor Larry. I asked him if he went ahead and just tried to take a pee in the basket, but he didn't do that.
But that was intentional, though, right?
I don't know. I don't know if it's like the guy in Wisconsin trying to mess up the vaccines, but I think I think maybe somebody just pulled from the wrong batch. I don't know if they really intentionally did it, or you never know. They might have intentionally did it, but at least you resolved the problem. That's the fun part of chemistry. Is a lot of times it helps you resolve problems, and occasionally you get stuck and you can't, but other times you're like, okay, here's what's really going on.
Right.
Yeah. Glad they didn't have to throw any blows before they found out what was really going on.
Yeah, that's crazy.
So, but on the 80s, we started doing a lot more with the plastics, and we started in the late 70s doing instrumentation. So this would be where, let's say you had a colorimeter, that was in the mid to late 70s, where you take a vial, you put the DPD in it, and you put it in the colorimeter. And in the old colorimeters that we had then, you would press the button, and a little needle, it was an analog scale, a little needle would go across on a scale you had behind it. It was the chlorine scale, the needle would go across and read 1.0, right? You pull that scale out, you put in the pH scale behind this needle, then you put the pH sample in with the phenol red, and that would go up and read 7.6. So the original ones were kind of these archaic-looking things we could show you pictures of sometime before the digital ones started coming out, more in the early 80s. And that's kind of where we've migrated from there. We started doing a lot of digital colorimeters to really make it so you could get a lot better readings on these colors. But one of the problems still is a key there was that you're using glass vials next to pools. So you had to grab the sample, get away from the pool, and do that. It wasn't until 1996 when we really designed a system that was... it was 1998, that we started to do the system called UDVs. And these are those unit dose vials. You maybe have seen them. They've been used a lot in swimming pool stores. But they're little spectrophotometer vials. They're only about 2 inches high. And we devised a way to put powders in each of those vials. So all you had to do was come along with a syringe, place the syringe in the vial, squirt the water in, and that was your chlorine test. You put it right in the meter, throw it away. You do that for pH, throw it away. So what that did is it took the traditional type of testing of, let's say, maybe anywhere from 7 to 10 minutes of doing a whole set of tests in a pool store, from copper, iron, all the way across if you want to do nitrates, but everything, hardness with titrations and all that. It took that from about a 7 to 8 minute test plus all the cleanup where they had to clean everything, dry everything, or else they're going to get bad results, to 3 minutes, you're done, and no cleaning required. So that was a really big shift, at least a paradigm shift in the marketplace. So we quickly had thousands of those labs out into the marketplace, and there's probably anywhere from 7 to 8, maybe 9,000 pool stores in the country, and we had a really large portion of those using those labs because they're so much faster and easier.
And at that time, was that for homeowners, or were there enough service companies out there that were wanting to buy those?
No, it was really the first, they all went to pool stores. There was a few service companies using them, but the cost per test was running about 20 cents each for each of those vials. And so the pool service guys are like, wait a minute, guys, I can get my whole set of tests on a test strip for 7 cents. I'm not blowing 20 cents a test. So it just wasn't designed for that end of the market. But it was, no, consumers wouldn't buy it. It was just for the pool stores. And they were learning, see, at that time, they were learning that Walmart, all these different mass merchants were eating their lunch on pool chemicals, so they had to have some way to get people in the store. And that's why it was critical to keep people coming in the store. They wanted to have this nice full-size lab where they could run people through quickly, but if they had a line, people would leave and go to Walmart. So we want fast, but we want it real accurate, and that's what we did.
Right.
That's awesome.
Yeah, that makes more sense. They were in the pool stores. I thought they were going to the pool stores and people were buying them, but there was at the pool store so that people could bring their water in and get it tested. Right. Okay. Mm-hmm. And so, I'm curious, okay, what were the big pool store chains back in the 80s?
I know Paddock had some down there in your area. Let's see. Of course, Leslie's had some of theirs. Pinch a Penny always had some. A lot of them were independent. To be honest, when I first came to the market in '84, most of them were independents. And you would have some stores that were obviously just big BioGuard stores. That's just all they had was their BioGuard logo on everything, top to bottom, probably even on the toilet paper in the restroom. They just, everything had to be BioGuard. And to their credit, they did a great job. But there wasn't a lot of chains back then, not as many as what we see now with the Leslies and Pinch a Pennies.
So is that then, after that stuff happened, where does the WaterLink kind of come in play?
Yeah, so the good segue there is the original WaterLink, actually, I have to back up a little bit, was in 1987. So I'll visit that and then talk about the one with UDVs. In 1987, we launched the first WaterLink, which was for pool stores where it connected to a computer. And that's where you had the vials, you squirt water in the vials, reagent in vials with the water, and then you actually place it in there one at a time, but you still did titrations for hardness and alkalinity. But the whole idea was all those results would go directly into a computer, so you could have this basic, somebody's nephew going click, and out pops the whole resolution of how to treat that pool. Here's all the results, here's the ideal ranges on the printout, here's what you need to do 1, 2, 3. And so people loved that when it first came out. We had a lot of them out there, but the complaint was that testing time of like 7, 8 minutes or so, and that's when we went into what was called the WaterLink Express, which was actually the thing where we did the little vials to make it faster. So then I think your question is what transpired into getting into the new WaterLink system that we have today. And that was a pretty big transition. What's that? Exactly. Yeah. So what happened was back, I have some file folders on, I think it was around 2004, we were contacted by this guy out in California who said he and another guy had some designs where they worked with blood chemistry on thin disc. They had some experience. He had his experience in some of the compact disc inspection devices and things like that, and they had worked on a project for blood chemistry, but they felt this could be adapted to water. So I remember talking to him and finding that I thought he had some good ideas, but the regular CD that you and I put into the stereos, or if you still use any of those, would be way too thin. In other words, optically, if you send a light through that, you can only get so much color out of something that thin. And so we worked with them from 2004, and finally in late 2012, the product came to fruition. But it was a solid 7-year plus project, and I've got file folders a mile long about all the different parts that went into that. One was, of course, making these dried reagents that would go into this little disc. They come out of these micro syringes that we have here in our production area, and they have to be dried. They get taken through a tunnel. They're dried, and in some cases we have to come back and put a pellet in later. So like on the phosphate test, it's a 2-part test. But we had to figure out the exact way to put the reagent in there, to dry it, to get the water to mix in properly. And one of the key things we have patents on is not only the DPD in this type of disc, but also the mixing, because when you think about it, when you put a disc in something, you may have heard of like a centrifuge. They use these in hospitals to spin out the blood and platelets to get those things out. When you do this, that's all by pressure. We need to actually have things mixing. So what the developer helped us with was he actually came up with this idea of like little metal beads, steel beads that would go into the disc that would then stir as the thing rotated by having magnets on the outside of that disc. So inside the meter is an assortment of magnets that actually are high-low magnets, so the bead goes up and goes down as it's mixing around. When we first heard this idea about putting in steel beads into the disc, I was thinking, how's this going to work? Anytime you put a metal next to a reagent, something's going to happen, But what they managed to do is actually, if you look at it closely, it's kind of like, imagine like a figure 8, but with a really tiny top to that 8. There's a little section off to the side of that well that the bead goes into where the mixing can occur, but it's not in direct contact with the reagent in the well next to it. So this guy was brilliant who helped us do all this, and it really became an interesting project that for the first 3 or 4 years, I wasn't sure if it was going to come to fruition. My brother David LaMotte was our president for years until recently when he retired just a few months ago, but he really helped push this along. He saw, and I did too, but he saw what could come of this if we could do this, because ever since I said that first day I went into a pool show, somebody said, I wish I just had something we could squirt the water in and have it tested all for us. It's like this was really the home run that a lot of people have been asking for. So what happened at that point is we did a lot of work on this. Like I said, it took us almost 7 years to finally get it right. And when we did, then it came down to trying to make these things. And so I can tell you some more stories about that, more current stories, which are kind of interesting because we've been affected by COVID this year, a little bit about that. But what's happened is when we first came out with it, it was specifically for pool stores. We had a little dome-shaped instrument designed to just sit next to a computer because we knew that initially the service guys wouldn't want to take an expensive device like this out into the field. So we had this instrument that went right into a computer. It was basically a dumb instrument, which meant that the software did a lot of the work, and the instrument itself was mostly a motor-driven system. It's the old, what I call like the spider bike versus the 15-speed type of thing. So it did really well, and right away, of course, some of the service people said, hey, look, we want something like this. We had some people in commercial pools saying, we want something like this, but we had to add a display to it. And that putting on a touchscreen display was critical, really critical to get it into the commercial pool market, service market.
Yeah, it seems like there's so much back-end engineering that, went into this whole thing. It's pretty incredible that a lot of us kind of take for granted if you don't build it just like anything else. There's just so much that goes into getting things to where they are now, where you pretty much, squirting a syringe full of water into something and just hitting buttons and then just doing all the work. So
yeah, and it was designed just for your industry, and that's one thing that we're proud of, is that the whole idea behind the whole device was we got to give people in the swimming pool industry a really fast way to test water. They've been asking for this forever, and we got to find a way to do it and do it right and make it reliable enough that they get the answers they need. So it was thrilling for us to finally see that come to fruition. I think the main frustrations after that were just trying to get everybody's computer working with this. Because,
But it's pretty impressive. I mean, the chemistry is still applicable for pretty much, anybody that wanted these types of readings from water. I mean, if you had some kind of, if you're trying to test tap water going back into the pool or for your garden or something like that, and you wanted to run a water test to see what's actually in the water, it's still applicable for that. But yeah, I could definitely see it being, more useful on an ongoing basis for the swimming pool industry.
Yeah, we did. We saw the other industries that we already have some made for the drinking water industry. So there's not really a lot of them out there now, but someday you might have a guy come to your house to look at your water treatment system who has one of our spins sitting in his hand. We do have a fair number of them out there, but they're kind of slow to change. They have these little test kits with the little drops and reagents, and some of the old guys just don't want to change their ways. But we do have drinking water spin disc. We have aquarium spin disc and spin disc for fish farming. And right now, it's great to have a large menu, but we're getting clobbered with demand. So we've had to set up some new rooms. And, even though the Arthur H. Thomas Company, which is great, said, okay, here's the money to do it. One of the really big hassles we ran into this year, when we order a room like this, imagine a very large room with very large pieces of equipment that all have to run together with robots and things doing, we do have people in there, 4 or 5 people, but it's a big investment. It's probably anywhere from $500,000 to $1 million investment to get one of these set up. And we had ordered this room so it'd be to us by June of last year, 1st of June last year's, as in 2020, it's way back then. But we had this all set up, and we had, we figured out what our demand would be, pre-COVID. So in September of 2019, we're like, okay, we're all set. Then COVID hits, and everybody and their mother wants spin disc. And all of a sudden, the guy who basically runs the company, who makes this very customized equipment for us, he was dragged into doing machinery that is being used for medical purposes. So I don't know if it was a government thing or if we're seeing his machines now popping out all those vials you see on TV all the time, but he basically had to drop our product to do medical equipment, and it's because he was in California, Southern California, that if you weren't doing emergency type of production equipment, you had to shut down. So this is the way he was able to stay afloat during that time, but it meant that new machine that was supposed to be here in June just got here a few days ago. So that killed us this year. There's a lot of people out there that did not get, let's say, it's kind of like the U.S. mail system. I ordered something for my son is December 9th, and it only had to go a state and a half over, and it just arrived yesterday. It's like, so we've had a big challenge this year with that, and it's been a shame because, we hate to fall behind on things, but it's just the demand was at least 50% more than we had last year, and about 100% more than we expected, because we just did not expect, especially with COVID going on, we expected all sorts of things to shut down. But it's great to be in a position where you have backlog, but for us in the marketing and sales area, it's painful because we don't want to disappoint anybody.
Right. Sure. And how is Lamont doing during these times?
Well, health-wise or financial, which part do you want?
Both are important.
Yeah, well, I can tell you with great joy that during the first, let me see, so it was March 13th, 14th, around that time, everything started shutting down, and we were able to keep operating because one of the reasons is because we also do a lot of equipment and things for sanitation. So we sell test strips for restaurants and medical purposes. We don't test the medical, it's like if somebody's using a sanitizer, let's say in a hospital, they might have to test the effectiveness of the sanitizer. So since we're making things for a chlorine-based industry or a sanitizer-based industry, we were able to stay open. And in very late October was the first time we had a very small scare, but it was that someone visited here that left, and a few days later they had symptoms. They developed COVID, but fortunately no one in here had gotten it, and they didn't get it from here. They got it on their trip home, we think. So we thought, okay, we're doing pretty well. We're going to make it in the clear. And then, I think in the latter part of November, then early December, we had a few cases. And of course, as you would guess, it would be in the spin room where we're making disc and stuff like that. And these are things where, somebody has gone somewhere and, one guy just happened to have, let's say, someone that was close to him was a nurse, just, these things happen. But when you lose a day doing disc, that could be hundreds of orders that you cannot get out the door, hundreds, if not mega hundreds.
I was going to say, what do you do in a case like that? I mean, you probably have to clean out this room.
Yeah. The health department, first of all, what happened in the early part of the year, which set us back, is the health department came in and said, okay, you got to have these people separated by X amount of feet apart. We're like, okay, but these machines weren't made for that. So we had to slow down some of our production. Like, to give you an example, some of the test strips, you've probably seen these test strip bottles that go on those little blister cards that go onto the racks you see in pool stores and all that. We had a machine where 4 people work in a little circular machine. We had to basically shut it down or have one guy operating it, at 1/5 the speed. It's like it had to go so slow. He had to go from this station to that. So all of a sudden, the production and output, so our test strips, got a little behind because of the COVID regulations. And so to answer your question, when that breakout, what happens is, yes, you have to have a specialty group come in, clean the area, and you have to stay out of it for, I think, 48 hours, 24 to 48 hours. Fortunately, we had more than one spin room, so we'd have to shut that room down and hopefully, get all we can out of the other spin rooms. But we have these spin rooms running 24/7. So when you lose a room, it's not easy because these guys, we were so backlogged in the summer. We, for the first time in the company history, are working Saturdays and Sundays. So we actually had people getting overtime and double time because it was so busy, yet we had this demand there that we needed to fulfill. So, but fortunately, knock on wood, we haven't had anyone seriously ill. We all know somebody, probably third party, that's had issues, some old folks we may know here and there that have passed, but we are able to work with our health department very closely, and they're good about coming in saying, okay, you got to do this, and alerts go out to all the employees, hey, don't come in, in these departments. It's tough, because you do lose some valuable time when that happens.
Definitely, very difficult times, but glad you're all safe and healthy and getting through it. And hopefully there's that light at the end of the tunnel.
Yeah, we'll just keep this on for the rest of the time. Put a mask on.
I think we got some good distance. Where are you at again?
It's like Maryland.
Maryland, yeah, we got some distance for sure. So how many LaMottes have actually, worked for, LaMotte?
There's been 15 over the years. Years ago, because my grandfather started it, and then he started to have his sons and daughters working there. So my aunts and uncles worked there for a long time. And then we had my brother and some other cousins working here. So 15 of us over the years is a good number. And it's been great. My brother, I think recently, he's really spent a ton of time just working here for years. He started when he was 18. And so he was the older brother. I didn't start here till I was 24. So I was like, you go ahead and you do the president job. I don't want that job.
I was going to say, what is that like? I mean, they're just, I can imagine being younger kids at the dinner table like, yeah, he's going to be the next CEO. This one, not so much. He doesn't have what it takes.
Yeah, originally I actually was working in a resort down in Ocean City, Maryland when I got out of college with a marketing and advertising degree. And I didn't really have interest in coming up here, but if you lived in this area, you'd know Chestertown is like a very small, imagine Mayberry or Hooterville. No, it's a small place, but it's very charming. It has a lot of charm. So once you get past your 20s, you're like, hey, this place is nice, But when you're in your 20s and you're living at the beach, having a good time, it was tough for me to give that up and come up here to Seatown, as we call it. Nothing was going on. But after a while, I think what's neat is when you're working with a small company, anybody can make a difference. We had somebody reporting on something recently where somebody found something that they could really make a serious difference that could maybe save us $400,000 a year just by doing something that she researched and really worked hard on. And when we do find, we have things set up, you've probably heard of lean initiatives and this stuff set up by Toyota, where they have these plans and programs where they really try to make things effective and efficient, and, they can make a suggestion. If it saves us money, they're going to get a piece of the action. So it's worth it.
Very cool. And are you kind of using more of that Kanban system that Toyota's, pretty much started from the very beginning back in Japan?
Yeah, you know about it. Yeah, it's we use that, and of course we have computer systems, but the problem these days has been making enough stock to keep up. And so we're getting some help in that area, some extra help to stock some things, because it's just, we don't want another year like we had this past year where we just couldn't keep up as well as we'd like to. I mean, fortunately, our sales were up, so obviously we grew, but we just don't want to disappoint anybody.
Right, because you do have some products that have a shelf life, correct? Mm-hmm. So it's difficult if you're trying to get ahead, because if it doesn't sell, you're too far ahead, mm-hmm. then it might have to be thrown away.
Right. So we have these rotation things going on, and there's dates where, someone in, let's say, back in inspection will say, wait a minute, we can't ship this out. This just came out of our work in progress warehouse, and it's already got 4 months off of it or something like that. So you're quite correct. We can't send that stuff out. And what's tough is sometimes if that goes to a distributor, if they don't, cycle it at the right time frame, then it could sit there longer. And one thing to tell you, too, for your listeners, most of the ones that people a lot of times ask is the shelf life that's on there, let's say on a bottle of strips, whatever, if it says 3/21, that means it's good. It should be good at least all the way through that month of March. And if you've kept it in a really good condition, you probably could get another month if you had to out of those test strips. It's just that under normal use, it's been tested. We do a lot of shelf life testing just to give you an idea how this is done. It's not just on the shelf, but these are accelerated studies where you put them in different types of ovens and moisture areas that you crank up the heat and run it for weeks and weeks at a time. And a certain number of weeks at a certain temperature and moisture can tell you what type of years it will have as stability.
That's awesome.
So cool.
Even though I'm not going to lie, you sound like my stepmom that was trying to explain. I was like, why is there ketchup in the fridge from 2018 or something like that? And she's just like, well, this is really what's going on. I'm just like, no. It doesn't matter. I don't care how good it tastes or smells. It's bad.
Well, yeah, what's good is some of the reagents you can tell by color. Like one of the things we always tell people, like the service guys are using DPD. If you take that second DPD reagent, there's DPD either 1 or 2, or in our case 1A, 1B, that second DPD reagent that you add, that adds the color, if those drops start coming out a medium to dark pink, you don't want to use them. If it's okay if it's clear. Clear is perfect. Light pink is still okay. It's when it gets that darker pink that it's going bad, and it's been out maybe in the sun or something's cooked it.
Is the stuff that's in, like, say, foil, packaged in foil, is that usually better longer?
Yeah, it's so much easier to keep moisture away from it. You could still, if you left those in the back of your car for all summer long, you can cook them, and that's not good for it, and it may turn a little brown. But as far as having these things individually sealed, it's a far better way, and that's why a lot of these have like 3 years or more shelf life. And when we sell reagents overseas, a lot of those guys want the tablet versions because the stability is so much better.
Yeah, put them in cans, like a bean can or something.
Yeah, exactly. But also, it's easier to ship. What happens is internationally, when you try to ship a reagent internationally, there's so many regulations now that just really are making it hard. They had this thing called GHS, which is Global Harmonized Systems, which, as you would think, would be great. Everybody has the same MSDS, the same safety little diamonds on there with the little warnings and all that. As soon as they came out, every other country said, we want to change part of that. And so now it's become far more work than it was led to, it was supposed to solve. It just created a nightmare. So it's a lot easier to ship strips and tablets around the world than it is liquids.
Right.
For sure.
So is there anything new or upcoming that you'd like to share with the listeners?
Well, I know that I'm trying to think of what they may not have seen or heard yet. I know that most people are familiar with our test strips. We have been working for quite a while on a new test strip app that you don't need a card for. You may have seen us and a few others try this, where you have a test strip, you dip it in the water, then you take a picture with your phone. And really, if you have a shadow over it, or if you do something awkward to it, it's just going to blow up and not be any good. We've been working for a while on one where you don't need to have a color card. The reason for a color card to go near that is that helps account for shadows and all these different things that would affect the lighting on that card. So we're close to launching something on that. We've been working a lot on software. We have what we call WaterLink Solutions, and WaterLink Solutions is something that people in the service can use for very little money. The WaterLink Service Pro is actually one that is more for the service route guys who really want to have all their details of like, okay, turn here, and here's how to leave a message behind as far as I was at your pool today, this is what I did, and all that. But we've also just been launching these new color cue meters, and I didn't mention that earlier, but the color cues are these small handheld meters designed to replace a lot of the visual testing. These are things that you may have seen, they're almost fit in your pocket, but you just place the reagent in the vials, you can put them in one at a time, and you get these results. But with the new color cue that we just come out with, it does have Bluetooth, so all those results can go right into your phone. You don't have to worry about writing things down, and it would go directly into your phone.
That's awesome. And where can people, find out more about all this information and just kind of keep up to date with what you all have going on?
Well, a lot of times they can go to their local distributor. Most of our local distributors have this information, but if not, they can go to our website. Our products are generally distributed through every distributor in the U.S., so you can find them virtually anywhere. And but if they don't have it and they can't find it, our website has a lot of that information. They can look under WaterLink Solutions for information on that. The test strip scanner app that we're working on, that's not out there yet, so that's hopefully only a few months away.
Very good. Well, we know you're a busy man. Is there anything else that you wanted to add before we wrap this up?
No, other than that, we're always open for ideas. I think we love to hear from folks out there. Every once in a while you get some of these things that are like, that's not a bad idea. And so, we're looking at other technologies. We want to stay ahead of the game, and we want to do what's best for the service pro. It's interesting because years ago when we first came out with our test strips, I remember sending a bottle or a couple of bottles out to Bob Lowry, who you probably know. He's written a lot of the IPSA handbooks and all that, and known him for years. And he went to a guy in San Francisco and said, okay, why don't you try this? And he just finished testing using another liquid kit. We won't mention brands. And he'd done his test, so he knew what his results should look like. And so Bob showed him, you just swirl this test strip, this was the original one, 3 times, and bring it up and read it. And the guy did this, and he said the guy froze. This is Bob Lowry talking. He froze and looked at him, and he was like, I just calculated if I use these strips, I could do an extra 4 pools each day. It's like, so it's funny how when you look at different things like that, how, and then we had some people that came to me at the Western Pool and Spa Show. I miss not going to that show because that's a lot of fun. First of all, the people there are great. Everybody's focused and they want to learn. It's like you got the perfect audience there. It's not just people building pools and, how much is this and how much is that. They really want to know what's going on. And so we've been able to get a lot of good feedback from that show. And I think one of the critical things is when we first actually went to that show, when we first went with that strip, the guys at Service Industry News did a really good job in that we sent them all this information that looked like a testimonial. And so when they printed it, it looked like a testimonial. So we had all these people come to the booth, and we were giving out free samples. And we had this guy, you may be able to share, we had an ad I think I may have sent to you to show some time of this guy who's dressed up like a police officer. So he's holding the bottle of strips, and he's got a bathing suit in the other hand, and it says, your strip search is over. So what's funny is that guy actually came out to the Western Pool and Spa Show, and he's standing next to me and this other woman that was working for us named Kathy. And if you went to the Western Pool and Spa Show, you probably knew this guy. I don't know his real name, but it's called Little Algae. He was like the little prospector. Yeah, so he was a character, right? So he's like, I got to take a picture with you. And so he comes around, and he tries to stick his hand around me and the police officer to give Kathy a pinch on the cheek. Well, he accidentally got the police officer. So it was funny. Poor Bobby, the police officer, was like, I didn't sign up for this. And it was just one of those funny events, and I remember, we took the picture when we were outside here, and when we dressed him up in this outfit, he looked at me, he's like, I'm not used to being on this side of the badge,
Excuse me? What are we dealing with here? I thought we did some background
I know,
checks.
right? Yeah, fortunately, I think he was kidding, but but I think what's great is I'm glad y'all are doing this show. I really wish you luck in the days ahead, and but if you have people that follow up with questions and something I didn't quite finish a thought on, or want to get some more information, just email me, and I can be real happy to help you out.
Will do.
Awesome.
Well, thank you so much, Richard. We really appreciate your time, and we wish you and LaMotte Company the best, and we look forward to hearing what you do in the future.
Thanks, Greg. Tyler, thanks for your time. I appreciate you doing this, and it's a big help to the industry to have you guys out there.
Thank you.
Appreciate it.